Agriculture has stepped into a bold new chapter, one defined by precision, automation, and scale. Across every continent, vast machines now sow, irrigate, and harvest with an efficiency once unimaginable. In this episode, we'll uncover how these powerful innovations are revolutionizing farming, driving the production of over 9 billion tons of food each year, and shaping the future of how the world is fed. Breaking through snow layers up to 10 meters thick, and even over 20 meters on the highest mountain roads of Japan, Switzerland, Canada, and Alaska, USA, these giant snowblowers are the true path openers of winter, keeping transportation from freezing under an endless sea of white. At the front, massive augers and steel blades spin at incredible speeds, crushing and lifting thousands of tons of snow each hour, then blasting it through a huge chute with such force that it can be thrown over 40 meters away. A 700 horsepower diesel engine allows the machine to push forward through ice and wind, while a system of precision sensors and hydraulic controls automatically adjusts the intake height to avoid damaging the road surface below. Thanks to high-precision mechanization, these machines can operate continuously in conditions of near-zero visibility, enduring fierce winds and sub-zero temperatures, in places where humans simply cannot reach. If your field is covered with stubborn rocks, this rock picker machine is the ultimate solution, designed to clean the soil faster, smoother, and with far less manual effort. At the front, sharp steel teeth dig through the surface, lifting and collecting stones weighing hundreds of kilograms without disturbing the soil structure beneath. Its powerful hydraulic system sorts and unloads the rocks within seconds, leaving a clean, level field ready for planting. With the capacity to handle 3 to 4 tons of material per minute, this compact yet powerful machine replaces dozens of workers while protecting other farming equipment from damage throughout the next growing season. On vast pastures, rice fields, and vineyards, the Kuhn Manure Spreader unleashes a powerful nutrient rain. Mounted behind a tractor, its massive twin-axle system can carry up to 20 tons of composted manure. As the hydraulic gate opens, the material is fed into the spinning beaters at the rear. In an instant, a golden mist rich in nutrients spreads evenly across the soil, reviving its vitality and fertility. With a reinforced steel body and a durable drive system, this machine frees farmers from the back-breaking, smelly, and dusty work of manual spreading, while reducing transport trips by up to 5 times compared to traditional methods. Say goodbye to the days of slow, back-breaking grass gathering. These giant rotary rakes are engineered to collect massive volumes of forage after mowing, forming perfectly even windrows ready for baling with unmatched precision and speed. With 4 rotors measuring over 3.8 meters in diameter and a working width of up to 19 meters, this machine can rake up to 20 hectares per hour, far surpassing conventional equipment. Its flexible steel tines gently comb through the field, collecting every strand of grass without picking up soil or stones, preserving cleanliness and nutritional value. A hydraulic suspension system automatically adjusts rotor height, ensuring peak performance even on uneven terrain, allowing European farmers to complete the harvest phase with remarkable speed and precision. Handling grass bales weighing nearly 1 ton in less than 2 minutes, the Krone Comprima Extreme is one of the most advanced assistants for farmers in Germany, the Netherlands, and Northern Europe, where large-scale dairy farming demands thousands of tons of feed reserves each year. At the front, a hydraulic compression system with a pressure of over 120 bar tightly compresses the dried grass into a perfectly round shape, while the baling chamber rotates continuously to ensure even density. Immediately afterward, the rear turntable automatically transfers the bale to the wrapping stage, covering it with 4 to 6 layers of airtight plastic film, creating the ideal anaerobic environment for natural silage fermentation. Owning this machine requires an investment of around USD 100,000 to 150,000, a significant figure, but one that is well earned by its unmatched power and efficiency. Across the bright orange pumpkin fields of October, the global peak harvest season, the massive Tumoba pumpkin harvesters begin to roll. Each machine can harvest over 1 hectare per hour using its synchronized cutting heads and conveyor belts to gently lift, cut, and load tens of thousands of pumpkins in a single shift without bruising, preserving their perfect shape. Every year, more than 28 million tons of pumpkins are harvested worldwide, with China, India, and Ukraine leading global production, while the United States is the largest consumer, using over 1.5 million tons annually. To meet the global demand of more than 70 million tons of cabbage each year, European farms are accelerating efforts to optimize every stage of the harvest. At small and medium-sized farms, a semi-automatic harvesting method is now widely used, a major step forward from traditional hand-picking. Farmers cut each cabbage by hand, trim away the outer leaves, and place it onto a moving conveyor belt. This method is labor-intensive, but delivers high precision and minimal damage, ideal for export markets that demand consistent size and flawless appearance. In contrast, at large-scale farms in the Netherlands, Germany, and Poland, where yields reach thousands of tons per season, fully mechanized cabbage harvesters have become the industry standard. At the front, a system of rollers and cutting discs gently lifts each plant and slices it cleanly at the base. The cabbages are then carried onto a central conveyor, where workers simply inspect and remove any damaged heads before packaging. Each machine can harvest 8,000 to 10,000 cabbages per hour, cutting labor costs by up to 70%, while keeping the supply chain running smoothly throughout the season. This gradual shift from manual labor to controlled automation shows how European agriculture is moving toward a perfect balance between productivity, efficiency, and quality, where people and technology work hand in hand across the fields. On post-harvest or deforested lands where the soil is compact and uneven, this spike wheel cultivator becomes the leading tool for land restoration. Each steel wheel, over a meter in diameter, rotates continuously, breaking up hardened layers, uprooting roots, and clearing debris from the surface. Pulled by a high-horsepower tractor, the entire disc assembly can process dozens of hectares per day, leaving the soil loose and aerated for the next playing stage. This technology helps farmers save up to 80% of soil preparation time, while reducing the need for deep plowing, minimizing erosion, and preserving natural soil moisture, a major advancement toward sustainable modern agriculture. From September to October each year in Ukraine, Russia, Argentina, and the United States, when vast sunflower fields dry and bow in the autumn wind, the harvest season officially begins. At the front of each harvester, a specialized cutting header with dozens of steel teeth skillfully separates the stalks and feeds the flower heads into a high-speed threshing drum. Inside, the seeds are stripped clean from their heads, while powerful air currents blow away husks and dust, and vibrating sieves sort out uniform, glossy black sunflower seeds. When the grain tank fills, an automatic auger unloads a flowing stream of seeds into a trailer moving alongside, keeping the operation continuous and uninterrupted. Each machine can harvest 5 to 7 tons per hour, helping the world produce more than 55 million tons of sunflower seeds every year. Yet, the price of this massive efficiency is growing concern over fine dust, emissions, and noise pollution that spread across rural landscapes. To produce 1 liter of sunflower oil, about 2.5 to 3 kilograms of seeds are needed, processed through a heat pressing method that maximizes yield but destroys much of the vitamin E and unsaturated fatty acids, and can generate free radicals if overheated. In the past, harvesting 1,000 hectares of silage corn required hundreds of workers and took several weeks. Today, with the support of high-capacity forage harvesters such as the Krone Big X, John Deere, or Class Jaguar, that enormous workload can be completed in just a few days. Each machine can easily process over 400 tons of corn per hour, equivalent to 20 to 30 times the manual labor productivity of the past. This record-breaking performance is achieved thanks to cutting blades spinning at over 1,200 revolutions per minute, a hydraulic compression system, and a chopping drum up to 800 millimeters in diameter, which shreds the entire stalk, leaf, and cob into uniform particles. It's not only faster, but also more precise and consistent, thanks to smart sensors that continuously adjust cutting length, moisture, and throughput in real time. This exceptional optimization has driven the rapid expansion of modern dairy farming, which is increasingly scaling up in size and efficiency, with both herd numbers and milk production tripling since the 1990s. Out in the field, the Ropa 6 emerges like a giant, transforming beast. In just minutes, its colossal conveyor arms unfold like wings, rollers and hydraulics come alive, and the machine transforms into a towering monster capable of devouring entire mountains of sugar beets. At the front, a set of rotating rollers and sweeping paddles continuously scoop beets from massive piles onto the conveyor. Instantly, they pass through a series of rollers and high-speed brushes that strip away soil, stones, and leftover leaves from the harvest. With a processing capacity of up to 1,500 tons per hour, the Ropa 6 turns what once seemed a tedious task into a powerful, precise, and seamless operation. And of course, to own this gentle giant, a farmer must spend more than $560,000. Pulled by a John Deere crawler tractor with hundreds of horsepower, every rotation of this wheel of destruction can rip out massive roots as thick as a man's leg, grinding them into fragments mixed with the soil. Dozens of razor-sharp steel teeth mounted around the wheel dig deep into the ground, crushing old stumps, tangled roots, and even hardened earth. In just a few hours, a rugged landscape full of roots and obstacles is leveled into soft, workable soil, ready for cultivation or construction. This unusual machine is a deep soil aerator, capable of digging and loosening the ground down to 90 centimeters, an impressive depth compared to conventional plows. It is specially designed for fields that have turned as hard as concrete after years of farming or neglect. As it operates, massive steel tines penetrate straight into the soil, breaking up compacted layers and opening air and water channels. This allows new crops to develop deeper roots, absorb nutrients more efficiently, and restores vitality to the field. Next, we encounter a remarkable machine on the vast grazing fields. The barbed wire fence machine, a specialized device designed to replace manual labor that used to be time-consuming and extremely dangerous. In the past, stretching each strand of wire and driving every wooden post required many workers and several days. Today, a single person can complete an entire project stretching for kilometers. Its structure includes a vertical reel system that feeds barbed wire, which is then pulled tight and positioned precisely with the help of hydraulic arms. At the front, a hydraulic crane is equipped with an automatic post driver. Each strike delivers a force of up to a ton, powerful enough to drive a wooden post 0.6 to 1.2 meters deep into hard ground within seconds. Everything happens fast, neat, and accurately. With the support of this technology, farmers not only save thousands of labor hours, but also ensure fences that are strong, perfectly aligned, and highly effective in protecting pastures and livestock. This is not a doomsday machine from a science fiction movie, but rather a flame weeder, an organic technology that helps farmers eliminate weeds without chemicals. Large gas tanks mounted on the tractor feed fuel to a row of burners stretching across the rear. As it moves, powerful flames sweep over the ground, rapidly heating weed cells until they are destroyed within seconds. Unlike traditional field burning, this method is highly controlled. The fire targets only the weeds without harming the soil or the main crops. However, while this method has the advantage of being eco-friendly, organic farm compatible, and leaving no toxic residues, its drawbacks include high fuel consumption, limited efficiency on very large fields, and the risk of fire spreading if not carefully managed. Hemp, an ancient crop that has been cultivated by humans for thousands of years, is now making a strong comeback as a green solution for the future. With ultra-strong fibers, nutrient-rich seeds, and the potential to replace plastics, paper, and even construction materials. Across these endless green fields, massive hemp harvesters emerge as the beating heart of modern agriculture. At the front, razor-sharp headers slice cleanly through dense stalks towering 3 to 4 meters high. Instantly, the conveyor system pulls the stems inside, where they are cut, gathered, and transferred directly into the trailing wagons, forming a continuous flow. One version that takes hemp harvesting to a new level is the Baler hemp harvester, a specialized machine that overcomes the shortcomings of earlier forage-style harvesters. Its dual cutting and gripping system allows the machine to harvest the seed-rich tops while neatly laying the sturdy stalks in long rows across the field for retting and fiber processing. In a single pass, farmers can collect both seed and fiber, preserving quality while minimizing post-harvest losses. Thanks to this technological leap, more than 300,000 tons of hemp each year can move swiftly from field to factory, ready to be transformed into textiles, nutritional oils, or eco-friendly biocomposites. To harvest bunches of celery that are juicy, delicate, and perfectly straight, farmers in leading producing countries such as the United States, Mexico, Spain, and China must put in tremendous effort. That is why the celery harvesting aid machine was created. A perfect blend of human precision and mechanical support. In the field, the front conveyors move slowly through rows of vibrant green celery. Workers cut each stalk by hand and gently place it onto the belts. Instantly, the celery is carried to the central platform, where other workers trim the base, remove excess leaves, bundle the stalks, and stack them neatly into plastic crates. The entire process unfolds like a living assembly line right in the middle of the field, from standing plants to neatly packaged bunches in just seconds. With this machine, farmers reduce the backbreaking labor while achieving yields of tens of tons per day, meeting the enormous demand of markets worldwide. Gone are the days when farmers bent their backs to lay every meter of plastic mulch by hand. Today, a single machine can cover an entire field with low tunnels in the blink of an eye. This is the low tunnel mulching machine, a specialized tool designed to protect tender crops like vegetables, strawberries, and melons. At the front, massive rolls of plastic film slowly unfurl. Instantly, the wheels press the edges firmly into the soil, holding the cover tight against the wind. Overhead rollers skillfully lift the film into graceful arches, creating endless rows of miniature tunnels. Beneath this transparent layer, the soil retains warmth, moisture stays balanced, and young plants are shielded from frost and pests. This method has been widely adopted in the United States, Spain, Japan, and China, where farmers save 150 to 200 hours of manual labor per hectare. In just seconds, massive banana stalks as thick as a leg are shredded into tiny fragments. This is the banana stem shredder, a specialized machine that helps farmers handle banana residues quickly and efficiently. As it operates, the giant rotating drum at the back, lined with razor-sharp blades, spins at high speed, pulling in the enormous stems, leaves, and sheaths. The resulting organic mulch is far from waste. It becomes a valuable source of green fertilizer. Returned directly to the field, it improves soil structure while providing nutrients for the next crop. This eco-friendly solution not only saves farmers the labor of clearing residues, but also reduces the cost of chemical fertilizers, creating a closed-loop cycle in banana cultivation. Strawberries are one of the most beloved fruits in the world. Today, more than 9 million tons of strawberries are harvested every year, stretching from China and the United States to Mexico and Europe. Faced with the growing demand for higher yields and with advances in artificial intelligence and vision technology, strawberry harvesting robots have emerged, bringing a new face to modern agriculture. Inside greenhouses, robotic arms extend, equipped with 3D cameras that continuously scan to identify ripe berries. Once detected, a soft gripper or vacuum system gently detaches the fruit from its stem and places it carefully into plastic trays. Every movement is precise to the millimeter, ensuring the strawberries retain their freshness and flawless appearance. With the global strawberry industry valued at more than $20 billion annually, these robots help secure supply for booming markets. While they provide consistency, 24/7 operation, and reduced labor costs, their drawbacks include high initial investment and slower picking speed compared to skilled human workers. Robots are already transforming farms and factories, but could they eventually take over the world? Harvesting dates from the tops of palm trees, nearly 30 meters tall, once meant risking life and limb on precarious ladders. In the past, a single worker could spend an entire hour collecting just a few clusters of dates, and accidents from falls were tragically common. Today, with the advent of specialized hydraulic lifting machines, this dangerous and exhausting job has been completely transformed. The long hydraulic arm of the machine can raise a steel platform carrying 4 to 6 workers high into the canopy, where date clusters weighing between 15 and 25 kilograms hang in heavy bunches. Here, workers can cut, tie, and lower the fruit safely within minutes. As a result, harvesting efficiency has increased 3 to 4 times compared to traditional methods, while the risk of accidents has been reduced to a minimum. This technology is now widely used in major date-producing regions such as Saudi Arabia, Egypt, Iran, and the United States, where millions of tons of dates are harvested each year to supply a global market worth billions of dollars. This is a super-class agricultural machine, often deployed in tough soils where entire layers of earth, meters deep, must be turned over for cultivation or land reclamation. On vast fields, it sometimes takes 2 or even 3 massive crawler tractors working together to drag the enormous plow behind them. Each machine unleashes more than 650 horsepower, roaring across the ground and channeling its full strength through heavy steel tracks. The colossal blades at the rear can dig as deep as 2 meters, flipping huge chunks of hardened soil that ordinary plows could never reach. Every pass not only shatters compacted layers but also recreates a loose, aerated structure, allowing the land to hold water and nutrients more effectively, laying the foundation for bountiful harvests to come. In the past, farmers would spend many days with shovels to manually clean irrigation ditches, but now a machine like this can handle hundreds of meters in just 1 hour. When in operation, its high-speed rotating bucket arm scoops out chunks of mud, stones, and debris from the ditch, then hurls them out through a conveyor system. Within minutes, an entire section of the ditch is cleared and unclogged, allowing irrigation water to flow smoothly and preventing flooding. This is an indispensable solution in large-scale rice, corn, or vegetable farming areas, where irrigation systems directly determine both yields and the survival of the crops. For decades, onion harvesting by hand, usually taking place from August to October, demanded hundreds of workers to pull, gather, and transport each bulb out of the field. The arrival of the first rear-mounted onion harvesters changed that. With a simple digging blade and a vibrating screen, they could lift the bulbs from the soil, remove excess dirt, and lay them neatly in rows. These machines are still common in the Netherlands, China, and India, where many farms remain small to medium in scale. However, the major limitation was that onions remained on the ground, requiring manual collection. To solve this, the next generation, harvesters with high elevators, was developed. They not only lifted and cleaned the onions more effectively, but also transferred them directly into trailers or trucks driving alongside. This continuous flow saved enormous amounts of labor and time, and such machines are widely used today in Western Europe, the United States, and Canada, where fields can stretch across tens or even hundreds of hectares. At an even larger scale, multifunctional trailed harvesters from companies like DeWolf and Simon pushed efficiency further. These machines added advanced leaf cutting and soil separating systems, delivering cleaner onions straight from the field and reducing the workload for post-harvest handling. The pinnacle of this evolution is the self-propelled onion harvester. Operating independently without a tractor, these giants feature comfortable operator cabins, GPS navigation, and precision sensors. Modern models such as the DeWolf Enduro or Grimm SE series can process 50 to 70 tons of onions per hour, replacing the labor of hundreds of workers. Each year, the world produces over 100 million tons of onions, with India alone consuming more than 20% of global output. Altogether, the onion industry generates over $40 billion US annually, a striking demonstration of its immense economic value and the role of mechanized harvesting in sustaining this demand. Gone are the familiar images of farmers holding handheld sprayers. Today, it is the autonomous sprayers that are redefining the future of modern agriculture. Across vast green fields, the John Deere See & Spray Ultimate extends its massive spray booms, gliding with centimeter-level precision. Equipped with advanced cameras, sensors, and artificial intelligence, it can detect individual weeds among thousands of crops, targeting only the areas that require treatment and reducing the use of pesticides by up to 90%. Its vision system is so advanced that it can scan up to 4,000 frames per second while operating at speeds of up to 15 miles per hour, ensuring unparalleled accuracy even across massive fields. Beyond cutting costs and protecting the environment, this breakthrough elevates farming into a high-tech industry where robots and AI replace backbreaking labor, delivering a level of efficiency never before seen in the history of cultivation. So, are you ready to invest $500,000 to $700,000 to own this cutting-edge machine? Seen from above, the rice field in spring in Japan looks like a giant canvas, where the machine quietly draws perfectly straight lines across the watery surface. The modern Yanmar rice transplanter eliminates the back-breaking labor of manual planting by automatically inserting young seedlings into the field, completely replacing traditional hand planting methods that once consumed so much time and effort. What makes this machine remarkable is its integration with a GPS satellite navigation system, allowing operation with centimeter-level precision. As a result, every row of rice is planted in flawless alignment, evenly spaced, and at consistent depth, minimizing both gaps and overlaps. In practice, a single Yanmar rice transplanter can cover 0.5 to 1 hectare per hour, up to 8 to 10 times faster than manual labor. During operation, the farmer only needs to steer and reload seedling trays at the back, while all movement, adjustments, and planting are fully automated. The synergy of precise engineering and smart satellite technology not only saves time and reduces labor costs, but also boosts productivity and crop quality, marking a new milestone in the modernization of agriculture. After 4 to 5 months of waiting for the rice to ripen, farmers in Japan usually rely on small Kubota combine harvesters. These compact machines are light, agile, and perfectly suited to the narrow plots and fragmented terrain of traditional Asian farming. But in the United States and Europe, the scale has been raised to an entirely new level. On vast open fields, giants like John Deere, Case IH, New Holland, and Claas operate with cutter bars stretching dozens of meters. Their mechanism works like a massive harvest line. The cutter slices the stalks, the threshing drum separates the grains, the fan and sieve system cleans away husks and straw, and the kernels are unloaded through an auger into a trailer moving alongside. Meanwhile, the straw is chopped and spread evenly back onto the field. This extraordinary efficiency, 40 to 50 tons per hour, harvesting hundreds of hectares in just a few days, is what has transformed the United States into a true agricultural superpower, far beyond the smaller machines of Asia. Hundreds of giant white snakes, stretched endlessly across the fields, are in fact grain baggers, modern machines that revolutionize grain storage in 21st century farming. After harvest, corn, wheat, or soybeans are poured into the hopper, where a powerful auger compacts the kernels and pushes them deep into massive polyethylene bags. These bags can stretch 60 to 75 meters long, and hold up to 250 tons of grain, the equivalent of a full-size silo right there in the field. Together, these three crops account for more than 2.3 billion tons produced globally each year, making grain baggers an indispensable solution for handling such vast quantities. No longer forced into a post-harvest rush, farmers in the US, Canada, and Argentina now turn their fields into sprawling mobile warehouses, a striking symbol of modern agricultural innovation. If this machine had existed 70 years ago, European farmers would not have had to spend months digging drainage ditches by hand. Today, in fields with heavy clay soils or areas prone to flooding, poor drainage can easily wipe out entire crops. To solve this, subsurface drainage machines like this are used. At their core is a massive plow blade mounted on a tracked chassis, capable of cutting 0.8 to 1.5 meters deep into the ground. As the machine advances, it simultaneously opens the soil and lays perforated PVC or PE pipes underground. Behind the machine, a large coil of pipe is gradually fed into the trench, which is then immediately backfilled, creating a hidden network of underground drains across the field. This system removes excess water after heavy rains while maintaining balanced soil moisture for crops. High up in the rolling hills of Europe, where steep and rugged terrain makes grass cutting with heavy machinery almost impossible, these compact drum mowers have become the perfect solution. Equipped with two cylindrical drums fitted with dozens of sharp blades, the machine spins at high speed to neatly slice through thick layers of grass, leaving behind evenly cut swaths. In just 1 hour of operation, a single unit can process 4,000 to 5,000 square meters of grass, a performance far beyond that of traditional handheld mowers. When started, the rotating drums generate strong friction combined with the cutting blades, creating a forward-driving force that allows the mower to move on its own without being pushed by the operator. Weighing only about 100 kilograms, its lightweight frame and flexible wheels make it easy to work even on steep slopes or terraced fields. Thanks to its mobility and impressive efficiency, this machine has become an indispensable workhorse for dairy, beef, and sheep farms, with a price of about $6,500. If you think the machine before your eyes looks like a giant clay-shaping press, you are mistaken. The peat harvester is a specialized machine designed to cut, crush, and collect peat, a vital resource used in energy production, organic fertilizers, and soil improvement. A massive cutting disc at the front digs deep into the peat layer, while the mechanical system grinds and compresses it into uniform cylindrical blocks. These blocks are then laid out in long rows across the field to dry naturally under the sun before being collected and transported. With its sturdy build and oversized tires, the tractor can freely frolic on soft, waterlogged ground without worrying about getting stuck, as if it were taking a mud bath. A modern peat harvester is capable of processing tens of tons of peat each day, leaving behind endless rows of neatly formed blocks stretching across the landscape. Across vast hazelnut orchards, the harvest usually takes place from late August to early October, with Turkey leading global production at around 800,000 tons per year, followed by Italy and the United States. Harvesting each tiny hazelnut by hand from the ground is extremely time and labor-intensive, which is why modern hazelnut harvesters like this have become the ideal solution. At the front, the machine is equipped with rotating sweep discs that continuously gather hazelnuts scattered among dry leaves and grass. Immediately after, a powerful suction system transfers everything into the processing chamber, where leaves, twigs, and soil are separated out, leaving only clean hazelnuts. Each day, a single machine can harvest several tons of nuts, all collected into the large rear container, ready to be transported to processing facilities. From June to August each year, across the vast fields of the United States, cucumbers destined for pickles are harvested by specialized machines. Unlike onion harvesters that dig bulbs out of the soil, these machines are designed specifically to separate the fruit from the plant while keeping each cucumber intact. Using a system of clamps and conveyors, the machine gently lifts the vines, detaches the ripe cucumbers from stems and leaves, and passes them through a cleaning unit that removes soil and debris. Thousands of fresh green cucumbers are then transferred into large storage bins before being offloaded into trailers moving alongside. In just 1 hour, a single harvester can handle tens of tons of cucumbers, replacing the work of hundreds of manual laborers. Today, although China is by far the world's leading producer of cucumbers, accounting for more than 70 million tons each year, the United States stands out with its advanced harvesting technology, especially for cucumbers grown specifically for pickles. From the fields, these cucumbers quickly make their way to processing plants, soon becoming familiar pickle jars found on dinner tables under brands such as Mount Olive, Vlasic, and Clausen. Flying just a few meters above the fields, agricultural pilots turn farming into one of the most daring and precision-driven professions in the world. With high-capacity nozzles mounted under its wings, a single agricultural aircraft can treat 300 to 600 hectares in a single day, achieving speeds tens of times faster than ground-based tractors or manual spraying. This massive efficiency has turned crop dusting planes into a strategic weapon against plant diseases. In large-scale farming regions, especially industrial banana plantations in Ecuador, Costa Rica, and Colombia, these aircraft are nearly indispensable for combating deadly outbreaks such as black sigatoka, a fungus that can slash yields by up to 50% if left unchecked. Yet, alongside their undeniable effectiveness, aerial spraying also triggers major controversy. With just one strong gust of wind, chemicals can drift for kilometers, raising risks of water contamination and health concerns for nearby communities. A machine that can literally mesmerize you, that is the stone burrier. A powerhouse that transforms entire fields filled with rocks into smooth, level soil in the blink of an eye. The working mechanism of the stone burrier is based on a high-speed rotating shaft equipped with sharp blades. As it moves forward, this shaft breaks up the topsoil, crushes and filters it, while pushing stones, weeds, and plant residues deep beneath the surface. On top, only a fine, fluffy, and level soil layer remains, the perfect environment for sowing and planting. This machine is especially popular in Europe, particularly in Italy, Spain, and France, regions with rocky terrain and soils used for vineyards, olive groves, and vegetable cultivation. Beyond Europe, it has also been adopted in high-tech agriculture in Japan and China, as well as in urban landscaping projects across Asia. Picture a giant iron plow carving perfect lines across the field, as if sketching geometry onto the soil itself. This implement is pulled by a tractor with a large V-shaped metal mold mounted at the back. As it moves forward, the curved wings push soil from both sides toward the center, compressing and shaping it into straight ridges with uniform height and width. This mechanism not only loosens the soil, improves drainage, and maintains moisture around the roots, but also creates the ideal environment for crops that require raised beds such as potatoes, sweet potatoes, sugarcane, corn, and various vegetables. This modern transformer machine is an exceptionally effective solution, designed specifically for orchards and widely used in major fruit-producing countries, such as Brazil, the United States, Spain, Italy, and Australia. Its operating mechanism is based on a powerful spraying system mounted on a massive U-shaped frame with a tank capacity of up to 4,000 liters. As the machine moves along the rows of trees, each spray boom can be adjusted in pressure and angle to release a fine mist that coats the foliage evenly on both sides. The multi-level spray design ensures maximum coverage from the base to the top, reaching even the inner branches that are nearly impossible to treat manually. Thanks to its ability to treat multiple rows simultaneously, the machine's efficiency far surpasses that of smaller tractor-mounted sprayers or handheld units. From that point on, orchards of oranges, apples, mandarins, or grapes no longer have to fear the rapid spread of pests and diseases, as they are cared for evenly, with less time and labor. Of course, owning such advanced technology comes at a price, around $18,000 to $20,000. Aeroponic potatoes are one of the greatest breakthroughs in modern agriculture. In this system, the roots and tubers do not grow in soil, but are suspended in the air inside tightly controlled chambers. Ultra-fine nozzles continuously spray nutrient mist directly onto the roots, providing all the water and minerals required. As a result, these seed potatoes are usually ready for harvest after 8 to 10 weeks, which is twice as fast as conventional cultivation. That is why, in a well-managed aeroponic facility, yields can reach 70 to 80 tons of seed potatoes per hectare per cycle, ensuring a stable supply and high quality for commercial production. However, this technology also has some drawbacks. The initial investment cost is very high, requiring misting systems, electricity, and climate-controlled greenhouses. Moreover, the plants depend entirely on the system. Any power outage or technical malfunction can put the entire crop at risk. Despite these challenges, the economic benefits are remarkable. Farmers and enterprises can recover their investment quickly, thanks to the much higher number of seed tubers, while also reducing the risk of diseases compared to conventional cultivation. This is why aeroponics is rapidly expanding in India, China, Kenya, and many European countries, becoming a strategic solution to secure clean seed potatoes and strengthen global food security. So what do you think about this method? Gone are the days of gathering straw by hand or stacking bundles onto horse-drawn carts, a backbreaking job that consumed countless hours. Today, across vast modern fields stretching to the horizon, massive tractors work side by side with JCB telehandlers, replacing human labor with raw power and precision. The telehandler operates through a hydraulic boom that can extend outward and upward, fitted with clamps or specialized forks to grip, lift, and move bales weighing hundreds of kilograms. Its extended reach allows it to stack straw bales high onto trailers or into storage barns, something ordinary forklifts could never achieve. Once loaded onto trucks, tons of straw bales are transported back to farms and storage facilities, where they are preserved as valuable feed, bedding, or even biofuel. Across Europe and the United States, the JCB telehandler has become the farmer's #1 assistant during the bountiful harvest season.